Hi, my name is Austin Powell. I'm a recent graduate with an MS in Statistics and undergrad degrees in Mathematics and Physics. For the past 2 years, I've been working first as a data analyst at Kaiser Permanente and now as an associated data scientist. I worked on many different types of data, including survey data, and big data prediction challenges within Kaiser. One of the projects that I'm most proud of at Kaiser Permanente is developing a machine learning algorithm using fuzzy logic and Bayesian statistics. For the data proposal for the data incubator, I'm really excited about the project proposal I have. I think it's a great opportunity for the open source community as well as many large companies who have different programmers and sharing code, and I think the recommendation system I have in mind would eliminate a lot of overlap in work as well as provide learning opportunities for those programmers. My data. To get the data, I used a simple Python script to query the API for last week's data starting on Sunday and up to the 29th. This project for the GitHub archive was started in around 2011 and the data for the public repositories, which this is pulled from, is updated every day. The amount of data stored on this repository is absolutely massive. Of course, the repository's committed is increasing as time goes on, so even more amount of data is gathered today, for example, than it was even just a year ago. And for my particular data set, I'm not even looking into the details of the data too much. My initial exploration was into the metadata. So when I talk about the metadata, I'm talking about the different events that are described on this particular page. And GitHub describes an event as something like a forking or a commit, as well as up to 28 or 26 different other events. And then within each individual event, there are different event, what they are calling payloads. So an event type and payload, so for commit event or create event, then they have all these additional different attributes that could be queried. So for my initial project, I spent a lot of time actually looking for a relevant data set and potential algorithm that I could develop that would impact the highest amount of users. And I really wanted to have meaningful work in addition to having the exercise of completing a project through the data incubator. So I actually did some fairly simple exploration because, as you can see, the amount of additional data that can be queried is absolutely massive. So I just actually pulled some of the metadata and I just looked at the different types of events over the past week. And this is fairly representative of what I've seen from other data set or analysis on the GitHub archive, where the majority of activity for any given day is done on the later afternoon over around like 3 o'clock. And then of course for any given week, the least amount of activity is on over the weekend, and then the following least amount of activity would be on a Monday. The next fairly simple view that I've given just to show, and again this is just to show the two types of models that I would like to build for this data set. The first, which I've already built for a previous project, which is a fairly simple Poisson regression where you're just looking at number of expected counts of commits or creation of repositories per day. And then based on those commits or repositories, for any person that's active on any given day, I would be able to recommend code to them or sections of code that are currently trending and potentially related to the current project that they are on. So this is actually a fairly interesting view, although simple, because it shows over the given week that I queried that the least amount of activity is actually are on a Monday, and Fridays follow the trend much the same as Saturday or Sunday over a given 24-hour period. So a lot of additional information, obviously, and questions could be asked about this data set, about user behavior. And one reason I find this particularly fascinating data set is because it's a look at growing technology and how people are interacting with technology, and in particular those people who are creating new technologies. And my recommendation system would look at benefiting those people and encouraging sharing of code and potentially getting more work done and learning for those particular individuals. So this is actually a view that I've stolen from someone else, but that I thought it was relevant because the amount of information that can be gathered from this data set is absolutely massive. And for my particular project, I would look at gathering all different kinds of information from other people and actually using that to create my recommendation system. This is a similar project. For my project, I did research different people who had done other similar analysis. The analysis for trending GitHub repositories has been done, and that's what this website is showing. However, no one has actually integrated that with recommending different types of code for someone who is actually coding. So if I were to create a use case, the use case would be either an open source project where someone is contributing to Python, for example, and then based on one of these trending repositories, when they commit to that Python repository, one similar type of repository or code would be recommended to them, and they would be able to potentially use that code to see what other work has been done. Another use case would be in a private large company where you have many different coders working on different projects, and from personal experience I know many of those projects can overlap. And so similarly, you would be able to look at what the trending projects are going on when there's a lot of activity, and then be able to recommend to those coders in different companies very similar projects and potentially save the company money, time, and have coders be able to look at different ways of coding for other coders within their company. So I hope you enjoyed my project. I'm really excited about it, and I hope to have the opportunity to develop these two-part algorithm through the Data Incubator.